All right, so let's now look at an additional example aside from those examples I have delivered in the general lecture about the integration by parts. And so this video here on this example, on this particular example, is intended to be viewed after you have watched the general lecture for integration by parts. And then again, along the way or at the end of the video lesson here, I am going to introduce what's special about this particular example that I brought up. Okay, and so let's get to it. The example we're looking at here is let's evaluate the indefinite integral. So the indefinite integral of the function x squared times cosine of x dx. Okay, and so in my general lecture, I brought in this guideline right here, the Liate guideline. And this is, back in my general lecture, this was a guideline that helps us to make a good U choice. And so at this moment, this problem does not look anything special. It's just like any of those, it looks just like, at first sight, it looks just like any of those examples I deliver in the main general lecture about integration by parts, in a sense that it has, I mean, the main function, the big function that we are about to integrate here, about to take the indefinite integral, already has it has two separate functions as a product right here, and we can clearly recognize that this x squared right here is from the algebraic function family, and this cosine of x in this product right here is from the trig family, okay, trig function family. And so in that way, you know, we're gonna have an easy time to apply to get ourselves aligned with this Liate guideline right here, and to make our U choice right here. And so clearly in this Liate from the left to the right, then algebraic function has higher priority. Okay, and so among these two functions, we know that cosine is one of those trig functions, and the x squared is a power function which belongs to the algebraic family. Then so I am going to now pick my U to be x squared. Okay, so again, the Liate is a guideline that helps us to pick a good working U choice right there. Okay, and just like how I explained in the general lecture, there will always be exceptions to this Liate guideline. However, in this problem, it is still going to work and with the Liate right here. Okay, and so once we have chosen our U choice, then du dx as the derivative of our function u in terms of x is going to be 2x. And then just like we have seen that a lot of times throughout the main general lecture, we can multiply this current equation here with the differential dx right here to produce du as a new differential equals 2x times the differential dx. Okay, so du equals 2x dx. And then on the other hand, right at that instance where we made our U choice, right at that instance, then think of this product again, the product that has x squared, it has cosine of x, and it has the dx expression. Then once we have isolated out, or once we have already set our U choice to be this x squared, then everything else aside from the x squared here, okay, so just like how I explained that in the general lecture, so everything else, meaning the cosine of x and including the dx, okay, everything else aside from the one that we chose for our U choice is now being regarded as a dv. Okay, and so that's a U and that's the dv. So that means apparently our integral here is already in a form of a U dv. Okay, but now right from this dv, we're gonna go ahead and find for ourselves, because right from this it's simple enough that we can find for ourselves the function v. So we can find v here simply by taking the indefinite integral of cosine of x dx. And this one here should be a simple indefinite integral for us to find. So v turns out to be sine of x. Okay, and just like how I explained in the general lecture about the integration by parts technique, then this small work right here, even though it's an indefinite integral, but we don't need to do the add c here. We can skip the plus c. Okay, so sine of x is perfectly good enough for us. Okay, but now we are ready to put the pieces together and advance to the next step. Okay, and so on my other board, and now I'm gonna have that formula for integration by parts again here. So this UDV, needless to say, that's what we should recognize in our beginning problem to be as. So our x squared cosine of x dx, the integral of that is now aligned with this UDV. So once we have identified that our function x squared cosine of x dx is the UDV, then we now can apply the right hand side right here to find our actual integral, our actual indefinite integral of this function x squared cosine of x. So the first term in my formula here on the right hand side, we need u times v. Okay, and remind yourself, u times v, u is x squared and v was found on our work right here as a consequence, was found to be sine of x. Okay, and so now I am going to put that together. So u is an x squared times v being sine of x. And we need to subtract, and the extra integral being part of the formula here that we have to produce here. So the integral here, the extra integral here says v times du. Okay, so v was this sine of x, and du was, so let's remind ourselves. So v is here, but du is the 2x dx. Okay, and so 2x dx, but putting it all together, I have to write it as a 2x times sine of x, and I put the dx at the end. Okay, so v and the product of those, that is of those two functions. That is our du right there. Okay, so v du is here. So we have our right to pull out that coefficient in front of the integral. So we produce in the next step, we produce the following: x squared sine of x minus 2 times the answer to this integral, x sine of x dx. Okay, so this is where I can start talking a little bit about why this problem in the beginning is special. It's special in the sense that throughout all of our examples, throughout all of the examples you have seen, you have watched in my general lecture, then we only took one step. I mean, we only had to, what I mean here is that we only applied the integration by parts formula once, and we got the problem done. That means this integral right here was so clearly back then throughout those examples in a general lecture. But here, even though we set it up, okay, and we got the first term down, and we ran ourselves into another integral that's still not quite so clear yet. So think about the plan ahead right here. We can apply the integration by parts formula again. Think of this as a separate individual problem on its own. Okay, and so I already used u and v for those. So how about s and t? Okay, how about s and t? So a naming variable is just a naming. So think about a new s, a new level of u, a new level of u actually. So s here, sort of like the u choice, but now I call it the s choice, the priority one, the one at the higher priority. So these two functions, there's sine of x in product with, there's x in product with sine of x, okay? So this is algebraic, this is L, okay? So the one that I first picked as the higher priority, instead of calling that the u as traditional habit, now I have to call it s, because I don't want to reuse the name right here, even though it's the exact same philosophy, but we apply the integration by parts on this little problem. Okay, so now s equals x, okay? And that means ds dx will equals 1, okay? Will equal 1, and then that gets me ds equal dx, okay? And so now I found my ds, I found my s right here, and so here I'm looking at, I can call everything else dt, okay? And so dt here was sine of x dx, everything else aside from the one we chose as our ds right there. Okay. So after we chose our primary choice right there for the substitution, then everything else was called the dt. Okay. And so now once we've had dt, then here it's going to be t so t equals the integral of sine of x dx. That's how we can find t. And so t here is going to be precisely minus cosine of x. And we can skip the c here. Okay, so another thing to mention that maybe it's also special in a sense that, we traditionally throughout many textbooks, we use a u and v for the integration by parts formula. But, if we change these to different variables name, it works fine too. Obviously, right here, I use s and t. So that means as a formula, just remind yourself. You see, instead of u dv, we can call that s dt. Okay, s dt. See, s dt. Our integral from beginning is recognized as an s dt, and then s dt here can be according to the integration by parts, s times t for whatever that is minus. Okay, the extra integral we produce here being t times ds. Okay, so I am going to quickly erase this quick line right here. So make sure you write that down before I have to to erase that. Okay, and so now the integration by part is going to happen again. And these are the pieces of information we need right here. So first term here still remains the same, but I intend to apply the integration by part on that integral. So now I'm going to still have x squared sine of x carried out from the first term from the previous step. And then I am going to have a minus 2 and allow me to erase the underline a and l right here, because I have left that there long enough. Okay, the coefficient 2 is here. I am now going to open a pair of parentheses. Okay, and so now we need s times t. S is here, and t is here. So that means we're looking at x times minus cosine of x. And so altogether it should be a minus sign right there. Okay, so that's s times t. And then I am going to subtract. Okay, and now the integral here, it's going to say what? T ds. So t is here, and ds is just that, dx right there. So t ds is minus cosine of x with the dx right here. Okay, and so let's clean up we can distribute that constant factor right there. We can distribute that common factor in the front. So x squared sine of x minus 2 multiplied with a negative term, it's going to give me a plus 2x cosine of x. But notice this extra term we just now produced has already been done with the integration. So we don't need to take the integral for the next step. This next one here is going to be, so the minus 2 multiplied with that minus sign is going to become a plus 2, but then this minus sign right here is going to come in and make it all negative. So it's really minus 2 times the integral for cosine of x dx. All right, so that's what it is for now, and we're almost done. So at this point, so this problem, it took us 2 times to apply the integration by parts formula. And then when we come down to this point right here, then we are almost ready. I mean, this is so ready for just the final step. And so now I need to get back to my other board to carry on with the steps here. So now all that work I've done here previously, we can now erase that. And so from the very last step, okay, x squared sine of x plus 2x cosine of x minus 2 times that integral here. Now we can go ahead and rewrite the first 2 terms, x squared sine of x plus 2x cosine of x, and now minus 2 times the integral of cosine. The integral, recall yourself, the integral of cosine of x is simply just sine of x. Okay, that's just a quick reminder. And so now our last term becomes, so it's minus 2 sine of x. But now as we realize we have come to the final answer at the dead end of our problem, then we don't forget to have the plus c. Okay, and so now this is going to be our final answer, or this is truly the indefinite integral of this starting function, x squared times the cosine of x. Okay, and so before I completely close down the example, again, go ahead and pause the video to use your derivative skill. Take the derivative of this. There are 3 terms here, and there could be product rule coming in all over. Take the derivative of this term by term to ensure and to make sure that this will land, the derivative of this will land into our original problem here at start, x squared times the cosine of x. Okay, and so again, before we're completely done with this example, what's special about this problem is that we had to apply the integration by parts twice. And so now I brought up this example to open up an idea that, so if I can take the integration by parts twice, then there will be problems out there. It may not be any of my example, you may not see any of my example, but just be ready, it will happen out there. If we can apply, if sometimes we have to apply the integration by parts twice, then there will be time, you hear my words, there will be time that we have to apply the integration by parts even more than twice, okay, 3 times, 4 times, or even 5 times, okay, and so even maybe I might not be able to cover all of those examples, but be ready for be open to that idea, because once again, I brought this up in the intention to show you that if we can take the integration by part twice, then as the further implication, we can take the integration by parts methods 3 times or 4 times. Okay?